Right now, while you're sitting wherever you are reading this or listening to this voice, there are approximately 200 billion trillion stars scattered across the observable universe, and not a single one of them, not one, has ever sent us a message. Not a signal, not a whisper, not even the faintest, most accidental pulse of electromagnetic noise that could be interpreted as hello. Think about that for a second. 200 billion trillion suns, many of them older than our own, many of them almost certainly orbited by rocky little worlds not entirely unlike ours. And the silence is so total, so absolute, so heavy, that it has a nay? Scientists call it the Fermi paradox, and if you have never lost a night of sleep over it, well, you probably have not thought about it hard enough yet, but you will. Because right now, something is pulling at the edge of your consciousness. The way a cold wind pulls at a flame, and that something is the question that may be the most important question our species has ever failed to answer. Where is everybody? Bueno, let us slow down for just a moment, because the best way to understand something enormous is to start with something small. Imagine, if you will, a clear night somewhere away from the city. Maybe you have had one of those nights. You drive out past the last gas station, past the last billboard, past the point where the orange glow of civilization finally surrenders to darkness. And you step out of the car and you look up and it hits you. Not as a thought first, but as a feeling. A physical sensation almost like vertigo, as if the ground beneath your boots might simply let go of you and you would fall upward into that impossible black cathedral of light. You can smell the dry grass and maybe the faint iron bite of night air. Your skin prickles in the cold, and every single point of light up there is not a decoration. It is a furnace, a nuclear furnace running at temperatures our bodies cannot survive for even a fraction of a second, burning millions of kilometers away, and yet somehow sending enough photons all the way to your retina that your brain registers it as a tiny silver dot. That is remarkable. That is astonishing. That is, if we are honest, almost too strange to be real. And yet, there you are. This small, warm primate standing on a spinning rock wrapped in a paper-thin atmosphere, staring into a void so vast that the light reaching your eyes from some of those stars left its source. Before your grandparents were born. Before their grandparents were born. Some of that light has been traveling since before the pyramids were raised, since before the first human hand pressed itself against a cave wall and left its mark. The universe did not wait for us. It was out there, burning and expanding and doing its enormous business long before any creature on this planet developed the narrow wiring to even ask why. Now, if that feeling, that mixture of smallness and wonder and something close to dread, if that feeling means anything to you, I want you to do something. I want you to sit with it a little longer than feels comfortable. Because that discomfort, that itch behind the eyes, that slightly breathless quality of standing at the edge of something too big, that is not weakness. That is the beginning of understanding. And if this kind of question makes your mind race, if the thought that we might be profoundly, cosmically, terrifyingly alone makes you want to understand more, then you are in the right place. Stay here. Think about it. And if you know someone else whose mind catches fire around questions like these, share this with them. Because the universe is too large and too strange and too important to think about alone. Now, here is where things get uncomfortable. And I promise you, by the time we are done, you will not be sorry we went here, but for right now, I need you to feel a specific kind of weight. Fíjate bien. Consider Mars. Beautiful, rust-colored, frozen Mars, sitting there about 225 million kilometers away at its farthest point from us. For years, maybe for most of your life, you have been hearing that humans are going to Mars. It is treated almost like a scheduled appointment. We are going. It is just a matter of engineering and funding and political will, and maybe you believed it. Maybe you still believe it. Maybe you have seen the sleek renderings and the hopeful press conferences and the rockets that really do launch and really do land again on their own legs like something from a science fiction film. And it all feels so close, doesn't it? It feels like the future is almost here. But here is the question that the glossy presentations tend to skip. Here is the detail that gets quietly set aside in the enthusiasm of the moment. What happens after you land? Not in terms of geology or resource extraction or the drama of first steps on alien soil. I mean, what happens to the body? What happens to the mind? What happens to a human being who has spent 7 months in deep space, bathed in radiation that our atmosphere normally absorbs for us, living in a metal tube about the size of a large recreational vehicle, eating Processed food and breathing recycled air and sleeping in a sleeping bag strapped to a wall? What happens when that person arrives on Mars, steps out onto the surface in a suit that must never ever fail, and then realizes, with a clarity that no simulation ever quite prepared them for, that getting home is not a matter of calling a car? That the next available departure window is not a few days away, but somewhere between 14 and 26 months away, depending on the orbital dance of two planets that do not care about schedules? Misigas? Because this is where the physics becomes personal. This is where the science stops being something you read about and starts being something you feel in your chest. A round trip to Mars, given current propulsion technology, given the way our two planets orbit the sun at different speeds and different distances, is not a weekend adventure. It is not even a year-long expedition. We are talking about a commitment measured in years, plural, with no emergency exit, no search and rescue, no possibility of turning back once you have passed a certain point. And the human body, this extraordinary and maddeningly fragile machine that evolution spent millions of years perfecting for one very specific environment, the surface of one very specific planet, does not handle that lightly. Mira, the bone density alone. Astronauts aboard the International Space Station, orbiting just 400 kilometers above our heads, lose roughly 1 to 2% of their bone density per month. Per month, the muscles atrophy. The cardiovascular system softens because the heart does not have to work as hard without gravity constantly pulling the blood downward. The immune system shifts in ways we do not fully understand yet. The vision of some astronauts is permanently altered because the fluid dynamics inside the skull change without gravity anchoring things in place. And that is in low Earth orbit, with resupply missions, with medical support, with the psychological comfort of being able to see the Earth out the window. Imagine all of that magnified by 7 months of travel each way, on a vehicle with no resupply option, no rescue, and the added insult of cosmic radiation that the Earth's magnetosphere normally deflects for us, streaming freely through the hull and through the body of every person on board. Now, I want to tell you about a morning that happened in Pasadena, California, in a building full of people who were not sleeping well. Not because of anything as simple as insomnia, but because they were in the business of thinking about exactly these problems. One of the engineers there, a young woman whose mother had driven her to every science fair from the age of 9, whose bookshelf at home had been colonized entirely by physics texts and worn paperback novels about expeditions to impossible places. This engineer sat down one morning with a cup of coffee cooling at her elbow, the smell of it already fading, her hands slightly cold even inside the warm building, and she opened a spreadsheet. She had been running the numbers on radiation exposure for a crewed Mars transit mission. And as she looked at the figures, as she traced the columns down with her finger, she felt something shift in her stomach. Something that was not quite nausea and not quite fear, but occupied exactly the neighborhood between them. Because the numbers, the honest numbers, not the optimistic projections, but the median estimates based on actual solar event data, suggested that a crew on a standard transit to Mars would absorb a radiation dose equivalent to being in the vicinity of a moderate nuclear accident, not once, continuously, for 7 months. One way. Her colleagues knew the numbers too, of course. Numbers like that do not stay secret in a room full of people whose entire professional lives are dedicated to keeping human beings alive in space. But there is a very human thing that happens when a problem is very large and the stakes are very high and the desire for a solution is very intense. You start to bracket the uncertainty. You tell yourself that the numbers represent worst-case scenarios. You remind yourself that solutions are being developed. Shielding technology is improving. Pharmacological countermeasures are being studied. And all of that is true. All of that is genuinely scientifically true. But the other thing that is true, the thing that does not fit as neatly into a press release, is that we do not yet know how to keep a human body alive and healthy and cognitively intact through a round trip to Mars, and not reliably, not safely, not by any standard we would accept for any other mode of transportation. And that is not a reason to give up. I want to be absolutely clear about that. But it is a reason to take the problem with the full weight of seriousness it deserves, rather than treating it as an engineering footnote to be solved sometime before launch. Because here is the thing. Here is the part that reaches beyond the engineering into something deeper. The history of our species is littered with examples of what happens when we underestimate the difficulty of a Challenged because we wanted the glory of the attempt more than we wanted the honest accounting of the risk. And in a moment, I will tell you exactly what that pattern looks like when you zoom out to the scale of civilizations, because what happens to individual explorers who are not prepared is merely a tragedy. What happens to entire civilizations that are not prepared is something else entirely. But first, let us get something very clear about why Mars is so specifically, so uniquely difficult. Not compared to the Moon, which is 3 days away and well inside the Earth's protective magnetic bubble for most of the journey. Not compared to the space station, which is a short emergency return away at any moment. But Mars, sitting out there in its own orbital lane, separated from us by a gulf that light itself takes between 3 and 22 minutes to cross depending on the time of year. That distance is not just a number. It means that a radio signal sent from Mars takes up to 22 minutes to reach Earth, which means that any conversation between a crew on Mars and a mission controller on Earth involves a minimum round-trip communication delay of up to 44 minutes. Not seconds, minutes. If something goes wrong on Mars, if a suit fails or a habitat loses pressure, or a crew member has a medical emergency, the people on the ground who know the most about how to fix it cannot help in real time. The crew is on their own, completely, absolutely, with no safety net on their own. Loves, this is not science fiction drama being introduced for narrative effect. This is physics. This is the finite speed of light and the current size of our solar system combining to create a situation that no amount of engineering genius or institutional commitment can fully solve, at least not with the physics we currently understand. And that constraint shapes everything. It shapes the psychological demands on the crew. It shapes the medical protocols. It shapes what we would need to know in advance because there will be no calling for help when the situation is novel. It shapes in ways that are still being worked out what kind of human beings could survive as such a mission, not just physically, but mentally and emotionally. Pues let me tell you something that the people who study these things have found, and I want you to hold it in your mind because it connects to something much larger that we are building toward. Studies of isolated environments, Antarctic winter over stations, submarine crews, long-duration spaceflight analog missions, they consistently find that somewhere around the 4 to 6 month mark, something happens to human groups in isolation. The researchers call it the third quarter phenomenon. Morale drops, conflict rises. The small irritations that were manageable in the first weeks calcify into genuine resentments. Sleep patterns deteriorate to the kind of deterioration where you wake in the night with your heart beating too fast and the air in the room feeling stale and close, and you lie there in the dark counting the days and feeling the weight of every one of them still remaining. Cognitive performance on complex tasks begins to slide. And this is in conditions that are merely isolated and uncomfortable, not irradiated, not under the constant low-level threat of equipment failure that would mean death within minutes. Now imagine that is your crew, your small team of extraordinarily brave and well-trained and genuinely remarkable human beings, somewhere around month 4 of a 7-month transit, still 3 months from their destination, still 14 months minimum from being able to leave. Imagine that in that context, a dispute arises, or a medical symptom appears that the onboard diagnostic equipment cannot fully characterize, or the communication with Earth degrades during a solar event, and the silence, the literal radio silence, stretches for days. What does that feel like? Not as an abstract psychological concern, but physically in the body, in the chest. There is a specific quality to the silence of deep space that no amount of mental preparation can fully inoculate against. Astronauts who have spoken about it, the ones who have written honestly about their experiences in low Earth orbit, describe a particular moment that most of them seem to share. A moment usually at night when the rest of the crew is sleeping, when the reality of the situation lands with a weight that is almost physical, the smallness, the distance, the realization that the nearest other human beings are not across town or across the country, but across a void measured in astronomical units. And I want to sit with that for a moment because I think this is one of the places where the science and the philosophy converge in a way that matters deeply. The challenge of going to Mars is not primarily a challenge of rocket engineering, though that challenge is real and enormous. It is not primarily a challenge of life support systems, though those challenges are formidable. The deepest challenge of going to Mars, the one that keeps the people who think hardest about it awake in the small hours, is the challenge of human nature, of what we are, of what we evolved to be, which is creatures that need each other, Creatures that need the reassurance of sky and soil and the particular quality of light that filters through our specific atmosphere, creatures that are exquisitely calibrated to one environment and extraordinarily bad at pretending to be something else. And that, fíjate bien, is not a flaw. It is not a limitation that engineering should feel embarrassed about failing to solve yet. It is information. It is the universe telling us something about ourselves. And the most dangerous thing we can do is to stop listening to that information because we are impatient for glory. In a moment, I'm going to tell you about the 3 mental tools that actually help people think clearly about challenges of this scale. The tools that the best scientists and the best explorers and the people most likely to actually get us to Mars and back have consistently used, because what comes next will either paralyze you or free you depending entirely on how you hold it. But first, the great filter, because we need to go there. We need to walk right up to it and look at it without flinching, because it is the thing behind everything else we have been talking about. And pretending it is not, there is exactly the kind of intellectual cowardice that our species cannot afford right now. The Fermi paradox, that deafening silence we started with, that absence of any signal from any other intelligence across the entire observable universe, has several possible explanations, and most of them are not comforting. One of the explanations proposed by economist Robin Hanson and developed by many thinkers since is that there is something in the developmental trajectory of intelligent civilizations that acts like a filter. Something that most civilizations do not pass through, something that stops them. And the question that should keep you up at night, the question that is far more important than any single space mission, is whether that filter is behind us or ahead of us. If the great filter is behind us, if it was something like the extraordinary improbability of life arising at all, or the unlikely leap from single-celled organisms to complex multicellular life, or the specific chain of the events that produced creatures capable of abstract thought, then we are the lucky one. We made it through. The universe is silent because almost no one else got this far, and that is terrifying in its loneliness, but reassuring in its implication that our road ahead is, if not safe, at least navigable. But if the great filter is ahead of us, if it is something that technological civilizations consistently fail to survive after reaching a certain level of capability, something like the development of self-destructive technologies before developing the wisdom to manage them, or the failure to establish a multiplanetary presence before a catastrophic event eliminates the single planet, then the silence of the universe is not the silence of an empty auditorium. It is the silence of a graveyard. And we are currently building toward the same exam that every other civilization before us, if there were any, apparently failed. ¿Tiene sentido? The stakes, when you look at them this clearly, are not about the pride of being the first species to put footprints on another planet. They are about survival, about continuation, about the possibility that the universe might someday, somewhere, produce a mind complex enough to understand it, and that for now, as far as we can tell, we are that mind. We are it. The universe looking at itself through these small, fragile, enormously improbable creatures. And whether we continue to exist, whether we develop the capability to spread beyond a single fragile world, whether we cultivate the curiosity and the rigor and the honest intellectual humility to solve the problems that will kill us if we do not solve them, that is the question. That is the only question that matters at the scale of civilizations. And this is where the person watching from the outside, the one who loves someone who has given their life to understanding these problems, this is where their perspective becomes essential. Think about the families of the early astronauts. Think about the spouses and the children who watched their people disappear into training schedules and simulations and committees, who understood only abstractly what was being attempted, who felt the danger not as statistic but as a cold presence in the house when the news was bad, a particular quality of stillness in the room, the way you can feel a storm coming before you see it, a drop in pressure, a change in the smell of the air. Think about what it means to watch someone you love orient their entire existence around a question that might kill them, and to understand, even without the equations, that the question itself is important enough to justify that risk, because that is what we are asking of ourselves as a civilization. We are asking the whole species to live with that tension, to feel the weight of the risk and choose to engage with it anyway, not from recklessness or naivety, but from the sober recognition that the alternative, the comfortable, incurious, complacent alternative, is itself a form of extinction, slow, quiet, and entirely self-inflicted. Bueno, so here is where we turn. Here is where the weight we have been carrying converts into something useful, because that is always the point, isn't it? The point is never simply to frighten. Fear without direction is just noise. The point is to see clearly, to see the full shape of the problem without blinking, and then to think. Really think? So let us talk about what thinking actually looks like when the problem is this big. The first tool, the one that matters more than any other, is what we might call proportional humility. Not false modesty, not the kind of hand-wringing that pretends we know nothing, but the honest recognition of the boundary between what we know and what we do not know, held with precision, not vagueness. The single most dangerous intellectual error a civilization can make is to mistake the current edge of its knowledge for the edge of all possible knowledge. To look at the problems we cannot yet solve and concluded that they are therefore unsolvable, rather than understanding them as the frontier. The living edge of the map where the work is actually happening. The people who made the most important contributions to our understanding of the universe, not just in physics, but in biology and chemistry and mathematics and engineering, they were not the ones who were most confident. They were the ones who were most precisely uncertain. They knew exactly what they did not know, and that specificity was their compass. Mira, take the radiation problem. The reason we know it is a problem is because people spent decades building instruments and flying them into space and measuring the environment with scrupulous honesty. They did not round the numbers in a favorable direction. They did not omit the inconvenient data. They published the findings and said, "This is what we are dealing with. Here's the shape of the obstacle. Now let us figure out what is on the other side of it." That is the posture. That is the intellectual stance that makes progress possible. Not optimism in the sense of assuming things will work out, but optimism in the sense of believing that honest engagement with hard problems is more productive than looking away from them. The second tool is what physicists call dimensional analysis, but which in practice simply means never letting a number float free of context. When someone tells you that a Mars mission would expose the crew to a certain level of radiation, the question is not whether that number sounds large or small in isolation. The question is compared to what? Compared to a lifetime of background radiation on Earth? Compared to the dose a radiologist might receive over a career? Compared to the threshold above which we have measured statistically significant increases in cancer risk? Numbers without context are just noise. One of the most powerful things you can do with your mind is to develop the habit of asking not just how much, but how much compared to what, and what does that comparison actually mean in terms that connect to human experience and human consequence? Mesigas, because this habit, this insistence on contextualizing every claim is not just useful for evaluating space missions. It is the fundamental skill of a citizen in a world where you are bombarded with numbers and statistics and projections and risk assessments, most of which are presented without the context that would let you evaluate them honestly. The person who has trained themselves to ask compared to what is almost immune to a certain category of manipulation. And in a world where important decisions about science and technology and exploration and resource allocation are made based on how the public understands the numbers, that immunity matters enormously. The third tool, and this is the one I find most beautiful, is the willingness to be wrong in public. This sounds simple. It is not. There is a deeply rooted instinct in human beings, probably evolutionary in origin, to protect our stated positions from revision, because in a small tribal group, being wrong was costly. It meant you had misjudged a predator or misremembered the location of water or recommended the wrong direction during a migration, and people might have died. That instinct is still in us. It runs deep. And in the social environment of modern life, where our opinions are visible to more people than any ancestral human ever encountered, that instinct is constantly being reinforced by the social costs of public revision. Changing your mind looks like weakness. Admitting you were wrong looks like incompetence. And so people hold their positions past the point where the evidence supports them, and they argue from momentum rather than from current understanding. And the conversation about important things like how to get to Mars and whether to try and what the real risks are and how to weigh them against the potential benefits, that conversation gets stuck in the amber of positions staked out before the evidence was fully in. The antidote is to practice treating your current understanding not as your identity, but as your best current approximation of the truth. A map that is accurate enough to navigate by today, but that you expect to revise when new terrain appears? Scientists who do this well are not people who have no ego. They are people who have learned to invest their ego in the quality of their thinking process rather than in the specific conclusions that process has currently reached. That shift is small and it is enormous. It changes what winning and losing mean. It makes being corrected into a form of being helped rather than a form of being attacked. And it makes the conversation about hard problems dramatically more productive because people can update and revise and change direction without feeling that they have betrayed something. Now hold all three of those tools in mind because I want to bring you to the place where this all converges. The place where the question of Mars and the question of the Fermi paradox and the question of human survival all point in the same direction. Here is what the silence of the universe might actually be telling us. Not that life is impossible, not that we are a cosmic accident with no significance, but that the transition from a single-planet species to a multi-planet species is extraordinarily difficult, not primarily for technological reasons, though those are real, but for reasons that go deeper, for reasons of wisdom, of patience, of the capacity to hold a very long time horizon in mind while managing the short-term pressures that are always louder and more immediately felt than the long-term survival imperatives. Imagínate por un momento a civilization a few thousand years ahead of us. Maybe they solved the rocket equation. Maybe they built the shielding. Maybe they cracked the propulsion problem and made the transit time a matter of weeks rather than months. But maybe they lost somewhere along the way the culture of honest inquiry that made those solutions possible. Maybe the institutions that supported patient, long-term, curiosity-driven science got hollowed out by the pressure of short-term economic thinking. Maybe the habit of questioning, the willingness to be wrong, the insistence on contextualizing numbers. Maybe those habits got treated as luxuries rather than necessities, as things you could cut when resources were tight and restore later when things were better, and maybe things were never better. Maybe the window that was open, the narrow window during which a species with sufficient intelligence and insufficient wisdom has the chance to develop the tools that could save it. Maybe that window closed, quietly, without announcement, pues that is the great filter as a cultural phenomenon rather than a technological one. And it is, I think, more frightening than the technological version because technology we can point to and measure and fund and develop. Culture is harder. The habits of mind that make a civilization capable of the long horizon thinking that survival requires, those habits are fragile. They are transmitted from person to person through education and example and the accumulated weight of a tradition that values knowing things honestly over feeling comfortable about what we think we know. And they can be lost. They have been lost before in smaller ways, in individual fields and institutions and communities, and the cost is always the same, a narrowing. A closing of the aperture through which the future is imagined. A creeping certainty that replaces the productive uncertainty that drives discovery. But here is the thing, and this is the thing I want you to carry out of this conversation because it is the most important thing, more important than any individual piece of science or any specific mission plan or any particular revelation about Mars or the cosmos. The habits of mind that make a civilization capable of survival are the same habits of mind that make an individual life richer and more honest and more fully alive. The proportional humility, the insistence on context, the willingness to be wrong in public and update and keep going. These are not just survival tools for the species. They are the qualities of a mind that is actually engaged with the world rather than defended against it. A mind that finds genuine pleasure in the moment of discovering it was wrong because that moment means the map just got better. A mind that can stand in a field under a night sky, feel the vertigo of scale and time and the vast improbability of its own existence, and respond not with existential paralysis, but with something that feels a lot like gratitude, because fíjate bien. The alternative to the terror of the cosmos is not the comfort of ignoring it. The alternative is wonder. Wonder is not the same as naivety. Wonder does not require pretending the problems are smaller than they are. Wonder is what happens when a mind that has been trained to see clearly looks at something genuinely extraordinary and allows itself to feel the full weight of how extraordinary it is. The universe is about 13.8 billion years old. For most of that time, nothing in it was capable of wondering about any of this. The atoms that make up your body were forged inside stars that burned and died billions of years before our sun was even formed, and those atoms spent unimaginable spans of time drifting through the dark before the gravitational accident of our solar system's formation pulled them together into something that eventually, through a chain of improbable events so long and so specific that describing it takes entire books, became a person sitting somewhere, listening to a voice talk about Mars and cosmic silence and what it means to be alive in a universe this large. You are made of stellar debris. You are the universe examining itself, and the question of whether we go to Mars, the question of whether we solve the radiation problem and the communication latency and the psychological demands of long-duration isolation, those questions are not just questions about engineering. They are questions about whether the universe continues to have something in it capable of asking questions. And I find that if I hold it right, not paralyzing at all, but rather clarifying, rather galvanizing, because the answer to the question of whether we are up to it is not predetermined. It depends on choices, on habits, on whether the culture that supports the kind of thinking that solves the unsolvable is maintained and passed on and treated as the essential infrastructure it actually is. So what do we actually do with Mars? Here's the honest, science-informed answer. We continue, we plan. We develop the shielding technology with the same rigor and honesty we apply to measuring the problem. We develop the medical protocols. We run the analog missions. We study the psychology of isolation with the same seriousness we bring to the orbital mechanics. We do not pretend the problems are solved before they are solved. And we do not pretend they are unsolvable simply because they are hard. We maintain with the same care a gardener brings to soil that took decades to cultivate the institutional and cultural conditions that make the work possible. And we do not lose sight, not for a single day, of why it matters. Not for the glory, not for the national pride or the corporate branding opportunity, but because if the great filter is ahead of us and we do not yet know that it is not, then the single most important thing our species can do is to become harder to kill. And that means learning to live somewhere other than here, which means solving problems that have never been solved, which means bringing to those problems the full honest force of the best thinking our civilization is capable of producing. Mira, the people who will actually walk on Mars, who will actually survive the transit and land and work and come back. And yes, I believe some of them will come back. Those people are almost certainly alive right now. They may be in school. They may be the kid who stays up past midnight reading about orbital mechanics because no one told them they were supposed to find it boring. They may be the engineer running spreadsheets in Pasadena with a cooling cup of coffee, feeling that shift in the stomach when the numbers say something uncomfortable, and choosing to publish the honest result anyway. They may be the researcher who spends years on a problem that most people consider already solved because they noticed an inconsistency that everyone else decided to bracket. The question is not whether those people exist. They do. The question is whether the world they grow up in gives them what they need to do the work. The intellectual freedom, the institutional support, the cultural permission to ask the inconvenient questions without being treated as troublemakers, and that, in the end, is what the silence of the universe is asking us. Not to be afraid, not to despair, but to be worthy of the question. To cultivate in ourselves and in each other and in the institutions we build and the children we raise and the conversations we choose to have, the qualities of mind that make a species capable of survival at the scale of the cosmos: curiosity, uncompromising and without apology; honesty, even when the honest answer is harder to live with than the comfortable one; humility, not about our potential, which is real and remarkable, but about our current knowledge, which is always partial; and wonder, that most underrated of all the cognitive virtues, the capacity to stand at the edge of what we know and feel, not the need to retreat to the safety of what we already understood, but the pull of what we might understand if we keep going. The universe is about 13.8 billion years old, and it has been silent as far as we can tell for all of that time. But you're here right now, asking the question. That is not nothing. That is, in the most precise scientific sense of the word, extraordinary. And the least we can do, the very minimum we owe to the chain of improbable accidents and ruthless selection and blind evolutionary luck that produced a mind capable of asking the question at all, is to keep asking it. To recede with everything we have, the comfortable sleep of the incurious. To treat our ignorance not as a reason for humility in the passive, retreating sense, but as a map of where the work is. To understand that the silence of the cosmos is not an answer. It is a challenge, and whether we rise to it or whether we become one more item in the long list of civilizations that almost made it, that is still beautifully and terrifyingly up to us.